Welcome to class number 2 for correlation and regression. So last time I introduced the basic idea of correlation regression and just talked about how it's a measure of association or a way of seeing if things happen together or at opposite times. I think some of the main things that you'll need to remember is that regression is a measure of central tendency, whereas correlation measures variability. Specifically, high correlations means that two things tend to vary together. They either go together or they happen at opposite times, one or the other. Talked about direction, strength, and linearity. Today what we're going to do is put that into practice and look at correlation. And then the next class period we'll look at regression. So this class period I'm going to show you the calculations for correlation only. And then how we use the hypothesis testing methodology to find out if we have a reliable or statistically significant correlation. I did a study, gathered some data. I think it'll make sense. So what you'll need for this is you need a calculator, and believe it or not, there's an R table you will need, just like it's a version of the T table. I've put one in the Google folder. I'm going to try to remember to link it when I share this video. All right, so here's the deal. I've heard some colleagues complaining on social media lately about student ratings of instruction. And some of the talk was about how some people think that students reward professors for being easy by giving them good course evaluations. And this is apparently something that people believe pretty strongly, at least some people do. And they were particularly adamant that it's the case with the website, which you may or may not know of, called Rate My Professors. So this is a website where you can go and learn about professors' teaching reputation and things like that. All right, so I decided that I would go find one of the people who was complaining about this through a teaching-related social media site. And that person on Rate My Professors had a score of 3.1 for how difficult she is, and then 4.2 for her overall quality. And both of those are on a 5-point scale. I decided it would probably be nicer for me to remove that person's name here, but it's pretty easy to find professors you might be interested in looking up. So anyway, I thought I would do this as a study and use faculty at Augustana. This person is not at Augustana, so I've gotten rid of that person's rating. Let me show you how I set up my data for this before we get to the hypothesis test. When we work the correlation, we can kind of conventionally use X and Y as the variables, X being that horizontal axis on a scatter plot. Here, that is course difficulty. And then Y would be the vertical axis on a scatter plot, and that would be the quality, the overall quality. And the first person I chose, I developed kind of a randomized method of choosing Augustana faculty. First person I chose had a 3.5 for difficulty and a 3 for quality. It's important when you set up this data that you keep each row dedicated to a single professor, because those two numbers have to go together. We're trying to see if these things are will both increase at the same time or if they move in opposite directions. So we need them tied together. All right, so what I'm going to do is gather data from 5 people that I'm choosing using a method that tries to randomize things. Those values are going to be filled in here. And notice that I've left a row down there. That's because I'm going to need the sums of squares, and so I want to be able to sum things up. This should be a familiar formula. This is the quick formula for getting the sums of squares for X. So we'll do that for difficulty. We'll find the sums of squares Y using the exact same formula. Notice here the only thing that's different is that there's a Y where there used to be an X. And finally, there's one more thing we need. This may look kind of new. It's called the sum of products, or the sum of cross products. It's actually the exact same thing, except we're cross multiplying. So if you want to think about what this means, think about this if we didn't use exponents. This would be the sum of x times x right there. Here, we've got the sum of x times y. So instead of multiplying x by itself, we're multiplying it by its neighbor. Up here, we have the sum of x times the sum of x. Over here, we've got, instead of that, we have the sum of x times the sum of its neighbor. So it's really doing the same thing. It's called covariance because it's not looking at how x varies, it's looking at how x and y vary together. So we're going to do that. What I'm going to do is put in these columns an x squared and a y squared. So 3.5 squared goes here, 3 squared goes there, and then here's this xy, the cross products column. That'll be 3.5 times 3. Okay? So it's just x times y, and we do that for all 5 individuals. So I'm going to ask you to do a couple things. I want you to fill in the table going across like that. Sum up your x's, sum up y, sum of x squared, sum of y squared, and the sum of x times y goes right there. And then use that to sum up these equations, or to solve for those equations. Okay, oops. So we got those 3 equations. I ask you to do that, hit pause, do that, come back, and I'll show you what I came up with. All right, hopefully you did this on your own. You didn't cheat, did you? All right, so I put in yellow the sums I have for each column. Make sure you get those sums. I double checked using Excel, and so I think I have those correct. If you get those wrong, see if you got these numbers correct up here in these columns, and let me know if you're not able to come up with the same thing I got. All right, so down here I've got my sums of squares. I filled in the numbers there and came up with 3.19 for sum of squares for x. For y, I filled in the numbers from the table there and came up with 3.07. And then for the sums of products, fill in those numbers there, came up with a negative 3.01. Just a quick note, these guys are squared values, so these have to be positive. Sums of products is not a squared value, and it can at times be negative. In fact, that's what we have here. We have a negative sums of products, which means we're going to have a negative correlation. All right, so that's getting things set up. We'll use those values when we get to step 3 of the table. Let's do the first couple of things here. The first steps in hypothesis testing is to write out a null and alternative hypothesis. Here the null hypothesis is written like this. That is the Greek letter rho. Okay. And that should not be he, that should be the. The null hypothesis is that rho, the population correlation is 0. So remember from the last video, 0 means no correlation at all. Now, we expect our samples to vary from that a little bit, but if we have a significantly different value, we are willing to say our sample will be something other than 0, or that there is a correlation. All right. So for critical values in step 2, a few things you should know. The R can be converted to T. It's very, very similar to T. So some textbooks will actually have students convert R to a T. We're going to skip that step and we'll just use R. As I was saying earlier, we have a critical table for R, and hopefully you've accessed that already. The other 2 things is that degrees of freedom is required to understand T. So degrees of freedom is necessary for R. Here it's n minus 2. The n represents the number of individuals in the sample. So I had 5 individual professors in the sample. And rather than doing n minus 1, we're actually calculating estimates for x and y. So it's n minus 2 in this case. Because R can also be directional, like a t-test, we could do a one-tailed or a two-tailed test. Now, I'm going to do a two-tailed test because I've never studied this before, and I can't really say for sure that it's going to be one direction or the other. All right, so the t-table I have here, pretty easy to use. Sorry, the R table is pretty easy to use. First of all, we're going to do a two-tailed test with an alpha 0.05. So I need to go up there. I have 3 degrees of freedom in my sample, so I need to go right there. And those two places meet at 0.878. Okay, 0.878. All right, so my critical value of R with 3 degrees of freedom is plus or minus 0.878 if I have an alpha with 2 tails, 0.05. All right, now it's an approximation of t. This is not a this is actually a t curve. It's not an R curve, but we're going to use it just sort of as a rough guideline. Okay. The way our critical values work is that the null hypothesis tells us that the correlation should be 0 if there's no correlation. However, because of sampling error, just depending on the 5 people we sampled, we should expect something. Maybe not exactly 0, but something in this range, even if it's true that there is no correlation. And that, beyond the critical value, gives us a significant value. So if our sample winds up beyond that confidence interval, we're going to say that there's a difference. All right, I need a little bit more room, so I'm just going to shrink that. Okay, so the formula then is this guy right here. That's going to be for our test value of R. I went back a couple pages and got my sums of squares values and my sums of products. So why don't you hit pause and fill that in to the formula and see what you get. We're wound up with these numbers. I got a correlation of negative 0.962. In my decision, what I'm going to do is take my 0.962 and reject the null hypothesis. I'm going to say there is a significant correlation. Now, the way I did that is there's my negative 0.962. I look up there and I see that it's in that red area. It's in the critical value, so I'm going to scrub that out. All right, so this is what that tells me. There is a correlation. I'm going to say that I rejected the null hypothesis. There is a correlation. What does that mean? Well, in this case, it means that there is a negative association between difficulty and overall quality ratings. So, because it's negative, that means the higher the difficulty, the lower the quality rating. I think that's what that's saying is that it looks like in the population, students rate difficult professors as having lower quality. I don't know exactly why. I'm actually a little bit surprised by that, but there you go. Now, it is possible that we've made a type 1 error. There's a 5% chance of that. We have to keep that in mind. And next time I'll show you how to think about like the strength of that correlation. So we'll be using the same data next time to do regression. All right, so here's the summary. Today, I added the hypothesis test for correlation and the calculations you need. So we've introduced this to what we learned last time. But notice we have not gotten to regression yet. That's our measure of central tendency. So next time we will do that. We'll calculate what's called the least squares regression line. We'll actually create a scatter plot. We'll make predictions based on that. So to do that, you want to make sure that you have your data from this class period. You'll want the sums of squares for x and the sums of products as well, because that's part of the calculations for the regression line.